Alrighty, 1.6 section is solving absolute value equations and inequalities. This section is going to be very similar to 1.4 and 1.5, where we're solving equations and inequalities. The only difference is this section is going to have the absolute value bars. So for this one, each problem is going to have two separate problems within it to solve for it. So we'll take a look what that means. So for this first problem, I have the absolute value of 2x minus 1 equals 5. Now, right when I see those absolute value bars, I'm going to make both problems right from the start. So since on the right-hand side I have this positive 5, then what this 2x minus 1 could equal, the absolute value of 5 is 5, and then the absolute value of negative 5 is also 5. So I'm going to set this 2x minus 1, this what's inside the absolute value bars, both to positive 5 and negative 5. So make my two problems, and then I'm just going to go through and solve both of these problems like I did in the equation section. So I'll give you some time to solve for them. You can check your work with mine to make sure it matches. When I solved the equation on the left-hand side, I got x equals 3. When I solved the equation on the right-hand side, I got x equals negative 2. Since these are equations, I'm just going to have closed circles, no shading. So negative 2 is a solution and 3 is a solution. If I plug them both back in to the original problem, both end up working. So if we try that, 2 times 3 is 6, minus 1 is 5. The absolute value of 5 is positive 5. If I plug in negative 2, 2 times negative 2 is negative 4, minus 1 is negative 5. The absolute value of negative 5 is positive 5. So both work. This next one, I have the absolute value of 3x plus 2 equals 4. I want to always make sure when I have those absolute value bars that this number that it's set equal to is positive. If it is positive, then I go through and make my two problems. If this number, once I got these absolute value bars by itself, is negative then over here, then it's going to be no solution. So for this one, though, it is positive, so I make my two problems, set one to positive 4, one to negative 4. Again, I'm going to give you some time to go through and solve for it. You can take a look at my work to check yours and make sure that you agree with it. We get x equals 2/3 and then x equals negative 2. So I have two closed circles, one at negative 2 and one at 2/3. This next one, notice the absolute value bars are not by itself on the one side, so we're going to get those by itself to start off with before we make our two problems. So I'm going to start off with adding 1 on both sides. So then these cancel out. So I have 3 times the absolute value of x plus 2 equals 9. Now notice this next step, I can't distribute this 3 within the absolute value bars because I don't want to take the absolute value of 3. That would change the value of the problem. So instead it's 3 times that. So to undo multiplication, I can divide both sides by 3. So those 3's are just going to cancel out. So I get the absolute value of x plus 2 equals 3. Now once I got those bars by itself, I check this number on the right to see if it is positive or negative. It is positive. So I make my two problems. I set one to positive 3, one to negative 3. I go through and solve each equation, and I get x equals 1 and x equals negative 5. If I'm unsure with my answer, again, I'm just going to plug the 1 back in for the x, simplify both sides down, see if both sides equal the same. I would plug in then the negative 5 in for my x, simplify both sides, and make sure they reduce down to the same. And then this is my graph over here, a closed circle at negative 5 and 1. This next problem, the absolute value bars are not by itself, so we're going to get it by itself. So I'm subtracting 3 on both sides. The 3's then cancel out. I get 2 times the absolute value of x plus 9 equals 4. They're multiplying. Again, I cannot distribute within absolute value bars, so instead I'm going to divide. These 2's then cancel out, so I get x plus 9 equals 2. This number is positive, so I make my two problems. If it were negative, again, it's going to be no solution. So I make my two problems, I go ahead and solve for them, and then I put two closed circles on those numbers. Alrighty, this next part, it says check for extraneous solutions. What that means, extraneous is an extra answer. So even though all my work shows that maybe these two numbers should work out when I plug them back in, extraneous might mean that one of them, when I plug them back in, does not work. So we'll want to check our answers on these next few problems. So for this first one, I have the absolute value of 3x plus 2 equals 4x plus 5. So I look over here. I want to get rid of those absolute value bars, so I make my two problems. I have 3x plus 2 equals 4x plus 5. And then for the second problem, I need to negate both of those. So this one is positive, now it is negative. This is 5 is positive, now it is negative. Or I could just put a negative out front, put this in parentheses, and distribute that negative to both of them. And then I solve the problem on the left. I'm going to solve the problem on the right. Okay, so please do that. Notice how we get x equals negative 3 and x equals negative 1. So that part is the exact same as the previous examples. What is different though, when it says in the directions check for extraneous solutions, we want to do that. So when I plug this negative 3 back in for my x's, like I did down here, see if both sides equal the same. So 3 times negative 3 is negative 9, plus 2 is negative 7. The absolute value of negative 7 is 7. Over here I have 4 times negative 3 plus 5, so 4 times negative 3 is negative 12, plus 5 is negative 7. Notice how both sides do not equal the same. I have 7 does not equal negative 7. So this one is going to be an extraneous solution. X equals negative 3. We're just going to X it out, meaning that it's an extraneous. Even though all of our work shows that it should work out, it does not when we actually plug it back in. Now let's go check the negative 1. So when I plug it in for my x's, simplify both sides down. I get negative 3 plus 2 is negative 1. Absolute value of negative 1 is 1. Over here I get negative 4 plus 5 is positive 1. Both sides equal positive 1, so it is a solution. So that one actually only had one solution, which was x equals negative 1. The negative 3 was extraneous, so I just X that out to show that. One more example showing whether it's extraneous or not. So I have this problem. I want to get rid of my absolute value bar, so I make my two problems. I have 5x minus 2 equals 7x plus 14, and then the second one, to negate it, I'm going to put the negative out front and then put that right-hand side inside parentheses, so I know to distribute the negative to both of them. I go through, I solve both equations. I get x equals negative 8 and x equals negative 1. So I need to check to see if they're extraneous or not. So I'm going to plug them back in to see if they work or not. You'll notice when I plug them back in, this first one is extraneous. Both sides are not the same, so I'm just going to X it out to show that. And then negative 1 does work, so I can put solution underneath of it or don't need to. Alrighty, the last type of problem that we're going to go through is solving absolute value inequalities. So for this one, we need to remember that anytime we're multiplying both sides by a negative or dividing both sides by a negative, that we need to switch the direction of the inequality. So the 5 is positive on the right hand side, so I can make my two problems. I'm going to have 2x minus 1 is less than 5. I kept everything the exact same, I just dropped the bars, but on this right hand side, when we have the absolute value bars, we're going to switch the direction of the inequality and make this 5 negative. So that's the two steps that we need to remember when it's an inequality. That the second problem, we need to switch the direction of the inequality and make that number negative. And then I keep just solving for both of them. Notice anywhere in my work, if I were multiplying or dividing by a negative, I would need to switch it. Even if it was the second problem that I already switched it to make the problem, I would still switch it again if I were multiplying or dividing by a negative. And then I need to graph it. So x is less than 3. I'm going to have an open circle at 3. It's less than that, so I shade to the left. X is greater than negative 2, so I have an open circle at negative 2, and I shade to the right. So anytime the original problem was less than 1, it's going to be an and statement, meaning that it's going to be shaded inwards. This next example, I have 2x plus 4, the absolute value of that is greater than or equal to 6. So I make my two problems. This first one, I just drop the bars, I write it the exact same way. The second one, I had to switch the direction of my inequality and then make that 6 negative. And then I go through and solve for both of them. I didn't have to divide by negative, so I kept the inequalities the same. X is greater than or equal to 1, so a closed circle at 1, it's greater than that, so I shade to the right. X is less than or equal to negative 5, so I have a closed circle at negative 5, and then I shade to the left of that. Notice the original problem was a greater than, so I shaded outwards. So it will always work that way. If it's less than, you're shading inwards. If it's greater than, you're going to be shaded outwards.